Okay, here you go. So we are talking about different kind of predictive analytics, right? So we talked about qualitative methods. So these qualitative methods are used when there is no past data. And then an example is again, let's say Apple is launching a new iPad and they want to get some understanding about that product, but they don't have past data. So what they're gonna do is do some focus group interviews or some surveys and things like that. But the problem with these methods is that they're subjective. So in contrast, quantitative methods are based on historical data. And we're gonna look at two different types of historical data. We're gonna look at causal models. So causal models basically assumes that there is a relationship between two variables. And we're gonna use that relationship to predict one of those variables. Okay, so regression is one of them. And we're going to see an example of that. We're going to see lots and lots of examples of relationships and it will be clear. But the main goal here is to establish this relationship, this causal relationship. Okay? So that's why these models are called causal models. In contrast, when we do time series models, we're going to see these time series models are based on just historical data. So what we're going to do in this case, for time series model, we are just going to look at data and try to find a pattern over time. Okay, so there is no causal relationship between variables. We are just going to look at the data and try to find a pattern over time. And then we will be extrapolating that pattern to predict the unknown. The goal of regression, the goal of any predictive analytics to predict the unknown, right? So we can do that based on some causal models like regression or time series models where we just look at the pattern. There are other statistical and AI models that we are going to not talk about in this class. So if you are following the book, again, the book is only recommended, not required. So I don't want you to take off financial burden by buying the book. It's a really good book. It's a good book to have in hand. But I'm gonna give you all the material that you need to succeed this course, right? Yes, Carter?
Dina, is the book included if you are on Smart Start? Do you know?
I did give this book to the bookstore people, so it should be included.
Okay, great.
So I think I'm following chapter 7 from the book. I'm not going to follow the book through and through because they have a lot of material that I don't think I can cover in class. So I'm going to take bits and pieces of examples from here and there from the book and concepts that I think are very important to understand. All right. Any questions so far? Okay. So we're going to start talking about regression. So as I said, regression is a causal model, right? That means the base of regression is going to be establishing a model or an equation which tells you the relationship between two variables, right? So what do I mean by relationship between two variables? So let's say, what do you think is the relationship between these following pairs of variables? So what do you think is the relationship between weather temperature and ice cream sales? And by relationship, I mean, do you think it's increasing or decreasing? Meaning, if weather temperature increases, do you think ice cream sales will increase or decrease or not matter at all? What do you think?
We think that they would increase as the weather increases, positive relationship.
Right. So it's a increasing or a positive relationship, right? So this is what I mean by relationship. What about social distancing and COVID-19 infections based on scientific theory? So what do you think if social distancing increase, will COVID-19 infection increase or decrease? Decrease? Yes. You can just say that. That's fine. Um, okay, so that's a decreasing relationship, right? What about the price of a gallon of milk and number of car accidents that happens on the highway beside the supermarket that sells this milk? Is there a relationship?
They're not related.
They're not related, right? So this is what I mean by relationships. So even if the statistician might be interested in studying this, but using regression, they should find that there is no relation. So the first thing that we generally do in regression is to do a scatter plot. So this is a descriptive statistics tools doing a scatter plot that you can use to show relationship between the two variables. And your scatter plot is going to look something like this, right? So for example, the first example that we give, right? The ice cream sale and weather temperature. So we think that's an increasing relationship. So that's what this scatter plot tells you. If you see a line like this, if you see your scatter plot is going up, right? That means it's an increasing relationship. If you see your scatter plot going down, that means it's a decreasing relationship. Now in this class, we're going to focus half of this regression at least based on linear relationship, but later we're also going to talk about non-linear relationship. Right? That means that it can increase. So this, you guys can see my cursor, right? Okay. So if, let's say it's still increasing, but the rate it's increasing is not the same, right? So first it's increasing faster, and then it's increasing in a much, much slower rate. So that can also happen. Well, we'll talk about that later. And then if the variables have no relationship, that means it's going to look something like that. So it's not neither going up nor going down. It's just haphazard over the whole region. Right? So that's a no relationship scatter plot. So whenever I give you some data, the first thing I would ask you to do is do a scatter plot. And that will, and for simple linear regression, actually scatter plot will also help you to write down regression model. We'll see that later when we see to this. So just so you know, you can probably tell that English is not my first language. Yes. So sometimes I'm gonna forget some words, and sometimes I'm gonna make up some words. And you can call me out on that and say that word doesn't exist. Let me explain. But just so you know, that might happen. It's just a caution. But so far you understand me, right? Yes? Okay. And this, you do want me to go slower or the speed is fine? Okay. Okay, cool. Okay, so what is regression analysis, right? So we are gonna take this learning that we learned from wait. So everything that we learned, the relationships, how does it translate into regression? So regression is basically establishing, as I said, relationship between two or more variables. Right? So sometimes the managerial decisions are based on these relationships. So sometimes manager will rely on intuition to judge how these two variables are related. But if we have past data, then we can solidify this and we can see how exactly they're related. So just saying increasing or decreasing relationship may not be enough to predict the future, right? So it's not giving you a particular number. It's just gonna give you, if you just say intuition tells you it's gonna be increasing relationship, then it's gonna give you some intuition about what it could be, but it doesn't give you a number. So we're gonna do regression analysis to basically get this number, to basically get the prediction about the variable that we are interested in. And to do that, what we're going to do is build an equation, which is called regression equation, based on its relationship with other variables. So in regression, and again, we're going to do regression for a month and a half maybe. So these things will become easier and easier to understand. So for today, just bear with me and take as much as you can. But if it's you feel like too many new things, just it's okay. You're gonna not feel that way in 2 weeks, I think. Okay, so in regression, two things are very, very important. This is the single most important thing maybe you learn in regression, because every time you do regression, the first thing you have to do is understand what is your dependent variable and what is your independent variable. So Excel will do the regression for you, but you have to tell Excel what is your dependent variable and what is your independent variable. Okay. Now, what are they? So as the name suggests, dependent variable is the variable basically that you are interested in, the variable that you're predicting, and that variable depends on something. That's why it's dependent. What does it depend on? It depends on the independent variables in your model. So independent variables are the variables that are being used to predict the dependent variable. Okay, so we're going to do a few examples, and that way it will be clearer. But whenever we talk about dependent and independent, sometimes I'm not going to say dependent the full thing or independent. Instead, I'm going to call dependent as y, and I'm going to call independent as x. A way to remember it would be, so dependent variable depends on independent variable, right? So independent variable comes first, and dependent variable comes second, right? So in English alphabet, what comes first, x or y? X, right? So x is going to be independent and y is going to be dependent. That's how you can remember. But we're going to do it so many times, I don't think you will have problem remembering this. All right, so let's talk about a few dependent and independent variables. So we're gonna we are going to look at the same examples as before. So before we only talked about what kind of relationships they have, right? Now I'm gonna pose a question, and that question will tell you what is a dependent variable and what is the independent variable, right? If we were to do a regression, and if you have this data. So let's say I'm asking, predict this year's ice cream sales based on the forecasted weather temperatures. So what am I asking you to predict? The sales, right? The ice cream sales. So that is going to be your dependent variable, because the ice cream sales depends on the weather temperature. Weather temperature does not depend on ice cream sales, right? Sun doesn't get up thinking what can I make my ice cream sales today, right? So weather temperature is something that is independent variable, and dependent variable is ice cream sales that you're predicting based on weather temperature. Does it make sense? Okay, so let's do the next one. So I'm asking, how does the spread of COVID-19 infection depend on the average social distancing in a society? So what is your dependent variable? And what is your independent variable? So whoever answers, answer both. Yes.
COVID-19 spreading, that's a dependent variable, and then the independent variable is the social distancing.
Do we agree? Yep, that makes sense, right? Very good. So COVID-19 infection depends on social distancing. So that's the dependent variable, right? Social distancing is the independent variable that doesn't depend on COVID-19. All right. How about the third one? So I'm asking, how does the price of gallon of milk depend? It should be depend, not depends, on the number of car accidents on that day. I mean, we can say that, but the statistician is crazy and he wants to do this experiment anyway. So what would be the dependent variable in that data? Would it be the price of milk or would it be the car accidents? If he wants to answer this question.
The price of milk is the dependent.
Right. So price of milk is the dependent, because the question that you're answering is, how does the price of milk depend on the number of car accidents? If the statistician was asking the question, how does the car accidents depend on the price of milk? It's a different question. So in that case, the dependent variable would be the coincidence, right? And the independent variable would be the price of gallon of milk. So it all depends on what question I'm asking to you. So whatever I'm asking you to predict or estimate or tell me what is the value of this, that's going to be a dependent variable. Dependent variable is what I'm interested in predicting, right? And in this class, all of your regression exercises, and your whole life, whatever regression you do, you will always have one dependent variable, something that you are interested in, right? But you will have multiple independent variables. So today we are only going to focus on one independent variable, but in general, you will have multiple independent variables, but only one dependent variable for one regression or one question. All right, so just the last one, predict demand of a product based on its pricing. What's your dependent, what's your independent?
Demand is Y and pricing is X.
Yeah, good. So demand is dependent or Y and pricing is independent or X. All right, so we feeling confident about dependent, independent? So in each question that you do on regression, you have to decide what's dependent, what's independent. Okay, so everything else depends on that. If you decide it incorrectly, everything else will be wrong. See, no. All right, talk about that later. So as I said, you will always have one dependent variable, right? Dependent variable is never going to be more than one. But you may have one or more multiple independent variables. So if you just have one dependent and one independent, that is called a simple regression. And today we're going to talk about simple regression. So we will have one dependent, one independent, that's it, right? But next class, we are going to jump into multiple regression, meaning that we will still have one dependent, but we will have two or more independent variables. Okay? All right, I'm going to take a short break, like a 5 minutes break. If you just want to walk around or have a cup of coffee. So I will be back. Let's do that now. And then, oops. What's the time? So, okay, I'm gonna be back at 1:46. Sounds good. All right. We are going to, if you want to work with me for this section of the class, we're gonna do an Excel work, right? So if you do want to work with me, the data file is the Butler data XLS. So I would have you download the data file. So one caveat is that for today, even if you're using online Excel, that's gonna work. But from next class onwards, I think we're gonna use an analysis toolpath for regression, for multiple regression. So that means that you need to have an Excel app application, right? Excel downloaded in your computer. It's not gonna work if it's online, okay? Okay, so let's start our first linear regression out of many. Oh, okay. Am I sharing screen? So all the analysis tools that we learn in this class, every tool that we learn, we are gonna learn it through an example. Okay. So because I believe that's the best way to learn this math thing. So we're gonna always start with an example. And for regression, we are actually going to use the same example over and over again so that we are not confused with the story. I'm just going to add more complexity to the story. So the basic story that we start today, it's going to be the same for all the classes we do in regression. I'm just going to add more variables sometimes, more questions and things like that. All right. So we are going to work on this model for the case of Butler Trucking Company. This example is from the book. So if you want to follow the book, that would be fine. So this trucking company is an independent trucking company in Southern California, and their business involves deliveries throughout the local area, right? Now the manager wants to develop a better work schedule, and that's why he wants to estimate the total daily travel time for their drivers, right? So just to do a better work schedule, he wants to understand how much time these drivers are taking. Now, of course, there are multiple factors, and again, like as we go on, I'm gonna add more and more independent variables or more factors in the question. But for today, we are going to assume that the manager believes that the total travel time, are closely related to the number of miles that they travel to make this delivery, right? It's a reasonable assumption, yes, that you're going to take more time if you're traveling more miles. So do you think it's going to be an increasing relationship or a decreasing relationship? You can also say like this or this. It's increasing, right? Right. So that's what we believe, but we'll see from the data if that shows up, right? All right, so the first question up is, in this problem, what is your independent variable and what is your dependent?
Dependent is time and independent is miles.
Everyone agrees? Right, so dependent is the variable that the manager is trying to predict or understand. That's the time, and it depends on the number of miles. So miles is the independent, right? So miles does not depend on time, but time depends on miles. All right. All right. So you're gonna see this model again and again. So it will get easier to digest with time. But basically, what we're gonna assume that we want to test if a simple linear regression model is a good fit for the data that we see. First, let me actually show you the data. And maybe that will make more sense. Let me show you the data. Okay, so this is the data that we have, right? It's a very simple data for the first class. It's just in this data, we have a data of 10 assignments. Each assignment has a miles and a time. What this means is the delivery person, whoever completes assignment 1, they have completed 100 miles to finish the delivery, and they have taken 9.3 hours, right? Similarly, for assignment 2, they have traveled 50 miles and they have taken 4.8 hours, right? So these are miles, and this time is basically in hours. All right. And then we understood that this is going to be my independent variable. Independent variable.
Excuse me.
Or
Do we have to like follow along?
no, you don't have to. Yeah.
Oh, okay.
Yeah, you can just because the how-to videos are loaded on Canvas, right? So you can just follow along on your free time and be prepared. Right? You can just watch and ask me questions and focus more on the concepts. Right? So this is my independent variable, or x, and time is going to be my dependent variable, or y. So we want to understand the relationship between miles and time. So what could be our first step to look at the data? A descriptive statistic test, a descriptive statistics test that we can do just looking at the data, whether they have an increasing relationship or not, that we think the data has. Right? So what could be a tool?
The scatter plot.
Exactly. So let's do a scatter plot list first. Okay. You probably know how to do a scatter plot already, but I'm gonna just show you for the completeness. And because we are going to use the scatter plot to finish our regression model as well for simple linear regression. All right, so to do the scatter plot, there is one rule that you have to obey is that your independent variable has to be on the left side. Okay, so if this is your data, your independent variable has to be on the left side of the data. And your dependent variable has to be on the right side. Now, sometimes in this class, in homeworks and exams, you will see data such as the dependent variable is on left and independent variable is on right. You have to switch spots to do the scatter plot. Okay? And the part of the reason is because whatever you are trying to predict or your dependent variable, that should be on the y-axis of your scatter plot. And that also explains the name, right? So the x or the independent variable should be on the x-axis, and the y or the dependent variable will be on the y-axis. Okay? So that's what we want. To do that, you're just going to select all of your data, and then you're going to do insert, and then here you're going to select scatter. In recommended choice, you're going to just select scatter and then the first scatter plot that you see. So you're just going to select that. You're going to do a lot of scatter plots in this class because the first thing I will ask you to do is scatter plot. Okay? A part of the reason is because I want you to form an intuition based on the scatter plot, and then that should match with the regression that you did. It's kind of a way to check if the regression you did is correct or not. All right. So you do that, and this is my scatter plot. So a plot is not complete without the labels. So we have to name the labels, right? There are, I think, multiple ways to do that, but one of the easier way would be just to select the plot, and then here you will see a plus sign. And if you see that, you're just going to select your axis title, and then you will edit that. So your x-axis is miles, and your y-axis is going to be time. If you don't see the plus sign, which is possible for older versions of Excel, then you would go to, once you select the chart, you will see a chart design option. And under that option, you will see add chart element. And there you will see axis styles. And there you will select primary horizontal or vertical or whatever axis you want to. Now, I wouldn't mind if you don't give me the vertical axis because that's your vertical axis basically, right? That's your time. But I would mind if you don't give me the horizontal axis, and I won't be able to give you full points if you don't give me that. So if I ask you to give me a plot, I need to see the tiles because otherwise I don't know what I'm looking at. You can also choose whatever chart design you like. I'm just gonna keep it simple and keep it just the original one. One thing that I also like to do is I generally don't like a lot of extra space in a graph, but again, this is cosmetic, so you can do or not do it, doesn't matter. But basically, if the data points are all over the plot, then that helps me see the relationship better. Right? So ideally, I don't want so much empty space. So basically what I want is that I want my horizontal axis to start from 40 instead of 0. Right? How can I do that? I just can double click on the horizontal axis to do that, okay? So once you select the horizontal axis, you just double click on that. Double click means clicking twice, right? So you just click like twice. You'd get the format axis. And here you'll see the minimum is set at 0. I want to set at 40. If you do that, you will see your empty space is gone and your data is it kind of looks better to me because just the way it's presented, I just feel like it's more readable. Any questions so far? If anyone followed and had any question, I'm happy to see. Or you can also stay back a little bit after the class and then I can walk you through it if anything is needed. All right, so let's go back to regression. And I'm gonna actually use this to explain. So this is basically what we do by regression. So we start with a model, right? Again, model means an equation. So we think that the dependent variable and the independent variable is related in this way. So we think that y, or the dependent variable, is equal to beta naught, that's a fixed parameter, plus beta 1, that's a parameter that's dependent on x multiplied by x, plus epsilon. So what is this epsilon? This epsilon is basically an error term, and that term exists because you can never explain the dependent variable with just the independent variable, right? For example, let's say think about the trucking company, right? The deliveries of the trucking company. You can never explain the time fully based on the miles, right? There could be other factors like the driver's mood. You cannot capture that. You cannot have data on that, right? Or maybe the driver just stopped somewhere because he had to meet someone, right? So there are always random factors, or maybe that day's weather. Maybe the weather is bad, maybe there is a random traffic. So there are always some random factors that is affecting your dependent variable that you cannot capture by just your independent variables. And that random factor is epsilon, or the error term. So what regression does is basically we want to estimate, and by estimate I mean we want to get the values of beta naught and beta 1 in such a way that this error is minimized, right? So that the randomness is minimized, the random error is minimized in the model, because then I can use that model to predict the unknown. So what we do is that we have this model, we start with the model, and then we have some data, right, x and y. Based on that data, we use a method called regression, or it's based on a least square error method, but I'll talk about that later. And regression gives us this equation, where basically your B naught is an estimation of beta naught, and B1 is an estimation of beta 1. And these estimations are created in a way that this error term is minimized. Okay? So all we want out of regression is this equation, that y equals to B naught plus B1 multiplied by x. And we say this, and statisticians would say that y hat, because that's going to be my predicted y, right? That might not be exactly what your y is because y has this error term. Although minimizing it, I'm not making it 0, or I cannot make it 0. So statistician would call this predicted y. Again, if you're lost a little bit, that's okay. We are going to talk about this model multiple times, right, in this class. So whenever we do different kind of regression, we're going to talk about this. But again, the basic idea is that we want to get this equation. Why do we want to get the equation? And by getting this equation, I mean we want to know the value of B naught, value meaning the number, right? And we want to know the value of B1, the number. If we have that, then for any values of x, we can calculate y. And that's why we will predict the unknown values of y. Okay, so we'll see that whole follow through. Let's go back to our regression. So this was our scatter plot. And for simple regression, again, the scatter plot actually gives you a very easy way to write down the regression equation, which is not going to be the case for multiple regression. In that case, you will have to write that down on your own based on the parameters. But we'll see that next time. So what you're going to do to know what is a regression equation, you are just going to select any of these data points, any of them, doesn't matter which one, and then you're going to do a right click if you're using Windows, and you're going to do a control plus right click if you're using Mac. Okay, so every time Windows uses right click, Mac is gonna use control plus right click. So once you do that, you will see something called add trend line. Once you see that, you're gonna select that. And in that, you want to make sure that linear is selected because I want to do a linear regression. I want to establish a linear relationship between y and x. Right? And right here, you'll see a box called display equation on chart. So you're going to select that. And for the time being, also let's select display r square value on chart. Okay, and I'm going to explain that later. So if you select those two, you're going to have your regression equation and your r square on the chart itself. Anyone having trouble? If you're following through, just let me know. Okay. So there you go. This is the regression equation. So now remember what we were looking for? We were looking for an equation which looks like this, right? B0 plus B1 multiplied by x. And what we got is y equals to 0.0678 multiplied by x plus 1.2739. If you're using Mac, again, your numbers might be a little bit different than mine, but it doesn't matter really. So what is my B0? If you just compare these two equations, what is B0?
0.0678.
Do we agree?
Oh no, 1.2739.
Yes. So B0 is a number that is independent of x, right? That is not multiplied by x. So B0 is 1.2739. Yes, we agree. And B1 is 0.0678. Okay. So what does this number B1, B0 really mean? So what does B1 really mean? Basically, B1 is the slope of this line, right? And what it means in terms of my data is this. So it means that I'm going to write it down. If the delivery requires 1 extra mile, then on average, the delivery will take 0.0678 hours more. Okay, so if you have to travel 1 extra mile, then you're gonna take 0.0678 hour more. That's what B1 tells you. So you just increase 1 x by x plus 1. So you're traveling 1 extra mile. That will increase your y by 0.0678. Does it make sense? Okay. So now, so if I ask you to write down regression equation, So whenever I ask you to do regression, I'll ask you to write a regression equation because that's how I know what regression you did. So how would you write? You would just follow the same pattern, right? Or this one. So you're gonna start with y. Now what is my y in this case? Time, right? You're gonna start with time equals to, then you're gonna write your b naught, right? You can also write b1 x first, but let's write b1 first. So 1.2739 plus 0.0678 multiplied by x. What is my x? Miles. So this is my regression equation. Any questions? So why is this regression equation important? Why do I need to write it down? Because this is the model that I'm talking about. Now let's say there is another assignment, 11th mile, and the manager knows that that assignment takes 100 miles. So what is the best prediction of the travel time based on this regression equation?
Can you repeat that, please?
Yes, so I'm gonna write it down. What? Let me do 120. What is the best estimation for travel time for an assignment that covers 120 miles?
Uh, 9.41.
How did you get that? Can you help us?
1.2739 plus 0.678 times 120.
Right, so you see what she did is just plugging in the miles in the model. Now we have a model, which is an equation. So all we need the regression equation to be able to tell or predict the time that is required to finish an assignment of 120 miles, right? And our best prediction would be just following the equation, 1.2739 plus 0.0678 multiplied by, you just do 120, right? You can just do 120 there, or you can just select the cell where I write down the miles. But either way, it's gonna be this, right? 9.40. Okay. Let's do one more. Maybe someone else can do this for us. What is the best estimation that covers, let's say, 80 miles? Or maybe 89 miles. How about that? Can anyone give me the number?
$7.30.
Let me see. So now, because I used a formula and now 120, I can just change this to 89. And that is the answer, right? 7.301. All right. So we basically covered two parts of our questions that you're gonna see in your homework or exams or classwork. So of course the regression is gonna get more complicated, but I'm always gonna ask, give me the regression equation. So I'm always gonna ask, give me a scatter plot. What do you think based on the scatter plot, right? Then I'm gonna ask, give me the regression equation. Then I might ask sometimes the interpretation of B1, that number. And then I'm gonna ask, give me a prediction, right? So I'm gonna ask like, what is the best estimation if these are the values of my independent variables, right? So these are the steps that you will probably follow in your exams or your assignments. One thing I did want to mention here, so this P1, the sign of P1 basically tells you what kind of relationship the two variables have, right? So if this sign is positive, that means it's an increasing relationship between the two variables. And if this is negative, that means it's a decreasing relationship. So in this case, the sign is positive, right? That means the relationship is increasing, which is what our intuition said in the beginning, which is also what the scatter plot shows, right? That's an increasing relationship. So again, the scatter plot is useful even in the case of multiple regression, just to check if your intuition, what it says, it matches the data, and it does match your regression as well. So the last thing that I want to talk about is the R-square. So I'm not going to talk a lot about what this R-square exactly is. In my slides, you will see some of the slides that I have are hidden. Yes, it is like a hide slide. That means that those slides I'm not gonna cover in class. Those are like extra readings and it's for your curiosity. And of course, if you have a question, you can ask me. But basically, in there, I explain how to get the R-square, what the R-square exactly is. For practical purposes, what we want is R-square because R-square tells you how good your model is. Now, what do I mean by how good? I mean that a better model means a better model has a higher predictability. So a better model predicts better. Okay. So we want a better model, right? We want models that are better because it will be able to predict more accurately. And if I am able to predict more accurately, that will help my business better because I can then adjust things that I want to adjust based on the prediction. Right. So a higher R-square is basically indicative of a better model. So we want a higher R-square, basically. So you just remember that we want a higher R-square. So the higher the R-square is, the better the model is. Okay. So in this case, my R-square is 0.664. Now, you can say it's a very low number, but remember that R-square is always going to be between 0 and 1. So it's going to be a number between 0 and 1. So anything above 0.5 is basically a good R-square. Okay. Now, if we had a different model where I had an R-square of 0.8, of course, that would be a better model. So when we end up comparing two different models, which we will do in this class, we will choose basically based on the R-square. So we will say which model has a higher R-square, so that's a better model, and you will use the better model to do your prediction. Okay. So again, this will be clear as we use these things multiple times, basically. Okay, so yes, one thing also, again, I'm not gonna talk a lot about this, but if you think about how Excel calculates its estimates, the values of B0 and B1, they basically use a method called least square method. And that method, basically what it does is it minimizes the total error, or it minimizes the total distance from the data points. So it finds a line, right, a straight line that minimizes the distance, the total distance from each of the data points. So it's not going to be just one of them, right? It's going to be the total distance. So it finds a line that fits the data the best. And by that, it uses this least square method. It basically is meaning that they do a square of error and they find the point where the square error is the least. Okay. Now, the reason they do square and not the error is because square is easier to optimize over because square function is a convex function. But anyway, so I digress, but basically that's where the name comes from. And that's why you see there are squares because they don't just take the distance, they square the distance and then they minimize. I guess we covered everything. Just to summarize, we talked about regression, right? So regression is a tool where you can understand how a dependent variable is related to an independent variable, right? And the simple linear regression model that we will follow is that y equals to b0 plus b1 multiplied by x, where y is the dependent variable, x is the independent variable, and regression gives you the values of b0 and b1. Right? And that's how you have the complete model, which then you can use to predict the unknown values of y for a given x. Right? And then we also learned that R-square is a measure of goodness of fit, meaning that it tells you how good the model is. Better R-square, higher R-square is a better model. The model with a higher R-square can predict better. So it's better for the business. I guess that's all for today. If you have any questions, please feel free to stay back, even if you have questions on the syllabus or class module or anything. If not, then I will see you on Thursday and then in person next week. Bye.
I have
See
a
you
question.
Thursday.